Okay, okay, okay. Shall we do this? So it's still running. And I tested on Windows, it just runs out of the box, so that's super nice. So more unknown territories, shall we? Yeah. So let's dive into it, cause you know what we're doing, right? You know what we're doing. I don't know what I'm doing, but so last thing we did was window title stuff. So window title stuff, and next thing, let's close a bit of this down because there's so much noise. So next thing is render untextured triangle. So render an untextured triangle. So how would I do this? And I'm gonna abstract one layer further than I usually would at this step, because I kind of know. Having a little cheat sheet here because I know where this is supposed to go. So render an untext. So in the Fiiish app, let's say here in the right here after the clear, how would I do this? So let's ignore textures, let's ignore shaders, let's ignore projection matrices, matrices, you know what I mean. So let's assume, and we don't do instance rendering, and in the end we want to render quads, right? So I mean, ideally at some point we have renderer draw quad, right? And then give it the position and size potentially. So, but right now, how about having something that says add vertex, right? And a vertex is X, Y, and Z. So let's just say, well, it's just X, Y, because our renderer is, well, do we want to add X, Y, Z? Probably not, because our renderer is two-dimensional, so we have something like this, and that gives us a vertex index, and then we have that 3 times. There will be help of wrappers, and then we say renderer at triangle and just say v0, v1, v2, right? And then we could add a force vertex and just add a second triangle and we have our quad, right? But let's do this. So let's use normalized device coordinates. So I wish I could draw something. So let's do the standard start triangle, right? So x is 0.0, the y is minus 0.5. Then we go to the left and to the bottom. This is just sample data, just to show the. Then we go to the right and to the bottom. Just like to align these. So we have top, then bottom left, bottom right, back to the top. So counterclockwise winding order. So this should add a triangle. Obviously our renderer doesn't know anything about this. So if we try to run this, I'm aiming for like 2 hours, but I want to do the triangle stuff. So that's not doing anything. So let's stop this out. So this is a clear. So let's say we have a pop function at vertex. That needs to mute self, x, f32y, and for simplicity, everything is f32. Just floats, no. And that returns usize of the vertex index. I mean, in the end, we don't have index data, but it's nice to kind of, for the caller, it's much nicer to do this, and this allows us to optimize later. So this just, I just wanted to compile without too much noise right now, and let's assume this always works. So we just show away if vertices set don't fit. So for now we just return 0, right? And then we have the pop function at triangle. Same thing. V0 usize. Maybe usize is overkill. Maybe we want. Let's make this more deterministic and use an U32, right? And this also always works. So we stop this out, right? And right now, no colors, no textures, no shaders, just run this, right? And yeah, we're not doing anything with the data yet, so nothing will happen. Obviously, so the usual warm-up. So that will come in a few minutes. So what I want to add is let's start to structure this a bit. So let's make a directory for the renderer and add something I like to call a material. So a material is basically something that can be rendered with one draw call. So it's all the vertices that share the same textures, if you have multiple channels, same shaders, same uniforms, right? We're only looking at the simple 2D case. We're not building a full-blown 3D engine here. So if I go to the material, struct, and I wish there was like a friend. So basically the material kind of abstracts this a bit. So what the renderer will have, so later the renderer will have multiple materials, but right now we have exactly one material, right? Probably this will become a pointer or weak thing or an index into. For now, it's just a material, right? And then here we have mod material. So this uses material, right? So why does my brain switch to C++ constantly? So okay, material doesn't implement debug, which is fine. So let's Make sure it does. I ate something wrong. Missing field material and initializer of renderer, which is fair. So this is temporary, but the reason I do this, I could just put all the vertex buffer objects into the renderer, but I know I'm going to remove them anyway, so we could just split it right now, right? So and we potentially copy too much. Do we need per material? So let me think through this. Is this the best way to do this? So this adds it to a local temporary thing, and this does. Maybe this is one copy too much. Because we're copying twice. I mean, nobody is gonna use this interface, so let's keep this simple. This is well, let's say vertices vec of potentially vertex. So we need a struct vertex, and we need to this will need to be extendable, and position is basically an array of f32 3 in this case, right? And this is just vertices. Probably we want to do something. Probably want to do pre-allocate size. Maybe this is not even a vector, but maybe even a fixed size array. Because here's the thing, when we call this, you can use it like this. So you cannot create vertices and then use them like 500 calls later. They're supposed to be immediately used. And it's just to make your life easier. We could just use add vertex and add them directly to the material instead. Which is probably the better way to do this, but that would imply we are in triangle mode, which I don't want. Everything is a triangle, right? Everything is a triangle. So interface to be tuned. Right now I just want a triangle and not overthink it. So what does add vertex do? Add vertex basically says, how can I create a v equals vertex from xyz. That's x, y, and 0, 0, right? And then we have an implementation for vertex to be rustified. That's probably a much better way to do this, but Right, so we get this vertex and then we say self dot vertices dot push, just the v, and then we say self dot vertices dot lengths, right, as u32. Does that make sense? So when we're done with this, so if we would do a if we would do a the clear is a placeholder here anyway, so if we would debug the renderer here, I hope that works. We would see the 3 vertices we just pushed, right? And we would see them every frame. Probably a bit noisy. So our vertices are in there, and actually interesting, when we do the begin frame, basically we do self dot vertices, because you see it gets longer all the time. So we push a ton, clear. Right, so now we only have our 3 vertices in that buffer. And it's always these 3, so it's always the 3 we pushed. I wish there was a way to kind of tell it to format it better, but let's say this is this. So then when we add the triangle, basically what we will do is, the interesting thing is, and also in the begin frame, the self dot material also needs a clear, and I'll show you in a minute why. So this has a pop function clear, for now doing nothing, but just so we don't forget. So when we add a triangle, we say for v in v0, v1, v2, right? Just to have a nicer loop. Go. Does this work in Rust? Yeah, we just, well, let's iter, just to be more explicit. Do I start to sound like that Bob Ross guy? Oh, I always forget this. Why? It's not associated, it's... So this works, so what we basically do is, we get our triangle, match self dot vertices dot get v. That's just an index. Technically, if any of these 3 is a non, we just skip it. So basically this is a panic, right? This is our buffer is wrong. Somebody did something very stupid. We should to do shout loud, right? We could check before and so we have a real vertex here, right? This is a vertex now. Maybe we pull the vertex out of the renderer. Maybe we pull the vertex out of the renderer. Let's see. So now we have to say self.material add vertex, and we just added, right? We just added blindly, and the material obviously needs a pop function add vertex, and that is mutable self, and that gets a vertex, which is a reference, right? And obviously we have no clue what a vertex is, so we need to use create renderer vertex. Pretty sure I messed up one level there. Oh, come on, really? So A, we have to deref, yes, but do we really have to do deref SU8, SU size? I mean, come on. So this means this is a temporary buffer, and when we add a triangle, we actually copy the raw vertex data into the material, and later if the material knows if it needs texture coordinates, vertex colors, normals, additional channels. So that should be fine-ish. Great, just checking if the stream is still working. So here now we have actually, and this is gonna be more interesting. So I have to check docker as vec. Wait, vector is rust vec, standard vec, yeah. So is the underlying data structure continuous memory? Pointer. Okay. Here it becomes interesting because we have to talk to OpenGL, so I'm wondering if this is actually continuous data on the heap. Pointer capacity length, so it's always is there padding in it? Continuous growable array type. Let's see, I mean, we won't be using this, but vertices like this, right? And then here vertices is back new, and here self.vertices clear, right? And then when we add a vertex, basically we say self vertices push vertex, right? And this is a copy, but that should be magic. Yeah, obviously we have to deref here because this is the memory copy, right? I would love to do this as a mem copy. Oh, wait, vertex can't be copy, right? There's nothing wrong here with it being copy. We want a copy there. Why can't I derive copy for, is it the, oh, can you, wait, I don't want to derive clone. Or is that array actually on the heap, which would be a bit ugly? I mean, so now that means if I run this, not very rusty, I apologize. We get the working version first and then we make it rusty, right? So the material actually also has a copy of the, why does it only have two? Because I am so here. What is V0, V1, and V3? Let's just do a quick. Do you see it? Yeah. Too much debug noise. So the is saying 1, 2, 3. Classic. So we say when we add the vertex, we return the length as so. If it's empty, we push to position 0, but the length afterwards is 1. So we want to do this, right? So we were off by 1, and that means the v2 wasn't found, so it wasn't copied to the material. So now we have 0, 1, 2, and then we suddenly have the 3 vertices in the material, right? And that's what we want. Kind of. So still building boilerplate that needs to be cleaned up, but as expected, 2 days. So I want to give this a render call, right? And that is, I'm not sure if this needs to be mutable. I would prefer renders to be non-mutable and have interior mutability, but for the moment I don't care too much. So at the end of the, so let's get rid of this debug, right? So at the end of the frame, we do some magic and then say self dot material dot render, right? It will need some setup and but for now, and sorting, but for now we have one material, so let's render that, right? So rendering is an interesting beast. So first thing we need for rendering, so we're gonna set some basics that are per material. So we need GL here, so we use, well, new style, right? GL, comma. It's private, isn't it? Oh, it's fine. So when we render, let's do enable GL blend, right? We want blending enabled. GL, come on, the blend func. We could just do GL1, but basically we want GL, the classic GL source alpha and GL1 minus source alpha, right? Set up basic blending to avoid surprises. Isn't this? It's func, it's not function. The autocompletion just tricked me there. And obviously all of this is unsafe, yes. Probably this whole function should be unsafe, but okay. So that is one part, right? I'm just checking that I don't miss anything. One thing we do for now is just let's say GL disable GL cull face and GL disable GL depth test, just to avoid ghosts, and cull face will be re-enabled, but for now. So that is that, and I'm actually looking at the, so if you're wondering what I'm looking at, basically the fish source has, well, this is the metal version. So the renderer here, OpenGLES source. So we have the renderer, which does a lot more, and I don't want to scare you away with this, so I'm looking that up on the side, and then we have a render effect, which is shader and texture, and then we have a material, which has a lot of nice stuff in there, and basically we're gonna look into this in a second. So yeah, give me a second to jump to the right position here. So what do we need? I mean, oh, this is interesting. I'm wondering if we shot ourselves in the foot with this setup and tear down. I'm wondering if we want to get rid of this, cause right now in the main, this will create a new renderer. Right, so the fish app new. Oh no, it won't create a renderer. So at the point where we create the renderer, we already do have a So the thing is, in the renderer, when we create the material here, this material here, we do it here. Okay, let's call this materials, and let's say we have a vector. And this is basically also a vec new, and then in hack create one material. So we say self dot materials dot push material new, right? And then here in the add triangle, we say if let, well, let's do the match. I prefer the match. Match self dot materials dot get 0. It's more like 0 equals active material, right? Later, but right now we have 1, and if we can't get an active material, so some material, thanks for frickin' the formatting, and otherwise we just do. I'm not too worried about performance at this point, so it's totally fine. So if we have a material and that ensures we don't new the material because we need the setup, because we need the load. So here it's fine, right? Let's just give it a quick go. If I copied something wrong or whoa. Okay. So yes, obviously. So let's do all of these. So this is for material in self dot materials dot iter mute to material dot clear, right? Clear all of them. And if there's none, well, clear none. That's step 1. What else did I forget? Well, same for the rendering, right? So in the end frame, we just render all materials and just note to self to do fix rendering order, because there's an order to stuff. We cannot just render random order in this case. Like transparent stuff comes last and background comes first in 2D, and so this probably looks more like it. Oh, the add triangle, wait. Oh, yeah. We need to get mute, right? That update wasn't too clean. I'm sorry about that. And there's one more problem. Oh, yeah. This is not the problem I meant, but this is a problem. Time to stand, yeah. Stand up. And obviously we need this to be a mutable reference here if you want to add a vertex, right? Wait. Maybe it's time to call it a day, actually, right? Oh. Yeah, maybe we want to get this as mutable, right? And then we can do, well, it's a mutable of a mutable, so wait. Now I'm getting confused. Okay. I mean, all I want is not to crash right now. That's all I want. Okay, so that's still working. So we assume that here, if I do a debug self here, I kind of expect it to have 3 vertices in every time, right? So we have the 3 vertices in here, so all we need to do is render them. And if this was OpenGL, old OpenGL with immediate mode, that would be trivial, but we need a buffer for this, right? So man, GL gen buffers, and I have no idea what the signature is. So basically we want to generate a buffer object name for our vertex buffer, right? So if I look at the GL bindings real quick, gen buffer, not an ARP, so that needs immutable types GLU int, right? So if I have, I have a types GLU int. Where is that defined? Is that GL types GLU int? So buffer is GL types GLU int. Was it GLU int? Did I mistype? GLU int, right? So, and this is buffer is 0. I don't want to make it an option because we need the target address and then we need to create it, and I don't want to go there. So private and public, private type and public interface. Yeah, fair enough. Let's fix that real quick. It's all temporary anyway because we're gonna abstract the hell out of this. I just want to reduce the number of warnings. So render a setup in the Fiiish app. Render a setup. That changes the signature of the renderer setup. So this is anyhow result, right? Yeah, that already looks a lot better. I'm not sure if I want to do that, dear Rust. Oh, it's mute anyway, so we're just passing it through. Would be a mutable. Yeah, so we technically don't need the window update context here. We just pass it through, right? We get it and we put it back in, but we don't need to understand the inside, so we don't need it. And app setup in the Fiiish main also use this result. That's better. So if I run this now, oh, we didn't do anything, we just did cleanups, but better safe than sorry later. So our buffer is 0, so let's generate the buffer, right? So so the question is, when do we generate the buffer? I think we generate it on the add mood as equals this, return as. I could just generate it in place, but basically g unsafe gl gen buffer gl man gl gen buffers. So gen buffers, this one here, and this will get a 1 and a pointer to the member. So this will need a 1 and a mutable reference to the buffer part of that, right? I'm not sure about the interface exactly in Rust. Okay, this looks good. So in theory, if we run this now, it shouldn't be a 0 anymore. Well, unless the first. So so we generated one buffer here, and it's 1. So technically, maybe this should be max GLU int. Do we actually have a max defined here? Max langs. Nope. We wrapped around, unfortunately. Oh, we didn't yet. But this is, yeah, we wrapped around now. So there is no GLU and max defined, which would be nice. Then we could use like something like that, which would make it much cleaner. Clearer. Well, and cleaner. But we do have a buffer, so that's fine. We might want to manually override the format to get some nicer output, but let's not do that right now. So we generate a buffer, and we can use that buffer later. Adding a vertex is just copying it basically into our vertex buffer, which is fine. So when we render it, now we render it. So if I open this man page, we need to bind it. I mean, we don't do the delete, we don't do cleanup, sorry, but man gl bind buffer. Basically, we want the target, and the target in this case is the array buffer. So array buffer. As an offset within the, yeah, so it's an array buffer. So when we and this is on render, right? So gl bind buffer gl array. The auto completion is scary, and that is self dot buffer, right? So that means we're binding the buffer, and from now on everything will use this buffer. Then we need to give it some data, and that's gl buffer. Oh, it's not here, but it's basically gl buffer data. So basically, it's maybe we can keep the data around and reuse it, but for now I don't care. To do, we might want to reuse this. If you have constant sizes for the materials, that might make sense. If it's constantly too small, it's buffer data, and the type is actually a GL array buffer. So it's an array buffer. I mean, it's an array buffer, so it's an array buffer. And then the second parameter is the size. And the size is in actual bytes, right? So oh, how do I do a size of in Rust? Actually, I want to keep this open. Mem size of standard mem size of core mem size of core mem size of sounds good. I mean, we could just hard code it because we know it's 4, but it's always nicer to. And actually, so let element vertex size equal this size of GL type GL float times 3, right? We have X, Y, and Z. We're kind of lying because we will support different vertex formats, so technically we should probably ask the vertex, but for now we just cheat. So this is, but the buffer data is vertex size times and vertex count, right? And vertex count, I'm just getting this explicitly, self dot vertices dot lengths len. Right, so this is the size of the buffer. Then the data is basically self dot vertices as pointer and the usage is basically a static draw. Right, so GL static draw. Static draw basically means here static will be used once and used many times. I mean, technically we should use dynamic, and but maybe stream would be better. Maybe stream, because static means will be modified once and used many times, and stream means modified once and used a few times, and technically it's modified once and used once, right? So we have the buffer data, and then we want to GL enable vertex attrib array. I mean, the autocompletion just does it for us, so coding by autocomplete. So this basically says which attribute do we want to enable, and I want to enable the, oh, there's a parrot. Wow, so we want to enable the, oh, that's nice, cause so basically, maybe we do that here. Pop in maybe we just hard code a 0 for now. We need to do something with the channels, but basically index is 0, and in C I would just use an enum and cast that to the GLU int, which I can't do in Rust. So I enable that, and then I have a GL vertex attrib pointer. So again, autocomplete. So that says gives us the attributes. So the index is 0. Let's attrib index equals 0. Just so we understand what's going on here. So this is this. Then the size is 3. So this is the size, and the size is number of components, so it's 3, x, y, z. We ignore the z for now, but we still want it in there for layer offset tweaks. We have the type, and the type is always, in our case, GL types. So no, this is just float, right? So this is a type identifier. So if I go here and say float, oh, if I go here and say float, I just wanted to, so it's basically this here. It's not the type, it's a type enum. Maybe, oh, we could use a pubconst to do that. Maybe we want to do that for our vertex attributes. Pubconst and then assign a number. This is GL enum defined. I'm curious how this. So this is just a. Oh, that's just a type. Okay. Okay, gotcha. Later optimization. So that is index type. Is it normalized? And actually, let's format this a bit more readable. Oh, that was actually the wrong space. So is it normalized? And that is actually GL false. I mean, vertex data is never normalized. Well, never. If it's a normal, it could be. And then it's, I think it's a vertex size, it's a stride, right? It's a stride. So basically how much to get from one vertex to the next, and that's basically this, because we pack them tightly, they're not interleaved. And then we need the offset, and this is a pointer. How do I do this in Rust? So basically what I do want is a 0 here, right? But I can't do that because it's a pointer. So it's a pointer of 0, and I have no idea in vertex size. Yes, we can do this. And then the other one is I size 2. Where is our checking? So my GL type, GL float. I mean, this is just a C float, right? Can't I do a size of, oh, so I mean, we do know that these are identical, right? Cheating, forgive me. So expected I32 found U size, so vertex count. Oh, thank you. Not a value, size of. How? Commem size of. Oh, okay. That's the syntax. So it's templated, so it's size of basically this. And then it probably also works with the GL float. Shall we try? Yeah, that was. So line 41, this does not need to be borrowed because it's just the value. This probably is correct as soon as I fix my stupid boo-boo. We want the size of the type, which is templated, which is rusty. Okay, maybe it doesn't work. It would be nice, but I don't want to get stuck on this. So expected I32, I mean that's easy. Technically we don't want it as I32, we want it as GL whatever. Wait, can you decide what you want? Oh. Yeah, all the functions want different formats, so we have to tell Rust to just do it for us. So expected I size found U size. So here we want an explicit as I size, right? We only wrap this once, so we're gonna get through this, and then we do all the rest, and then we circle back to this and do the. Oh, come on. I mean, you could just autocast this for me, please. You could just do intos and yeah. Yeah, come on. Let me have my extra. Nobody is hurt by these. Nobody. And it improves readability a lot, so. So. How. Can I just do. Can I just do into here? Probably not, right? Let's do this last and do all the others first. So what just to remove the noise. So this wants an eye size. Wait, what does it want? Expected I32. I mean, I'm not happy right now. So this is the one we're gonna fix last. This is the one where we don't know how to do it. So can I just do as conc void? Oh, conc void, it's obviously is it core raw c void? C void. It's core FFIC void. I hope. And now it's time to break this into a new line. This is ugly. I don't like this at all. Right now I just want a triangle we can talk about. So how do I get a buffer, a null point? I mean, so if I go into the random material OpenGL and say offset, so jump to definition. So basically we add the offset to a null pointer and then get a pointer that's relative. So I have no idea how to do that in Rust. So I'm gonna cheat, and we have far too many gluten. Glium. Yeah, we can close this, this, and then we go into Glium source code. And somewhere we have a vertex attrib pointer in there. Maybe if we're lucky, right? Probably not. So how do they do it? They have buffer offset plus offset as. They just do a s const star const underscore. I mean, maybe we can get away with that. I'm not so happy about this. But again, triangle first, nice later. I mean, what could go wrong, right? We're not doing anything, we're just setting the buffers, so worst case, we just wrecked our OpenGL status, which doesn't seem to be the case. Let's get rid of this debug, because we know it's good. So we enabled the vertex attrib pointer. Basically, we can draw arrows now, right? I mean, this is the offset inside the buffer, so if we had position and normals or position and colors or texture coordinates, we need to work that, but right now. And is that all? So basically what we want to do is man.gl draw arrays. So the mode is always triangle. We never do strips, we just do triangles. First is 0 and count is the count of triangles. So gl draw arrays. It's gl triangles. So offset is 0. We could split it down and okay, let number of triangles equals self dot. We have a vertex count somewhere. Vertex count divided by 3 as I32, I presume. Right, if somebody pushed wrong vertices, we'll round down and it will blow up in our face now. This will be so bad. Yep. So we forgot something. What did we forget? I mean, oh, we don't have a shader, right? we had OpenGL 4.1, so we don't have. Well, are we? Which OpenGL level are we? I kind of. I mean, we could do we could just do. I wonder if that we could do a so we could do a man gl get string. Is it get string and then just get the version? Maybe that's good for the renderer setup anyway. So in the renderer setup, when everything is done, we do an unsave gl get string gl version, and gl get string probably gets a, oh, it returns a pointer. It does return a pointer. No, that's interesting. Stealing from my other project, which is upcoming, so. Oh, maybe steal from the older project. Maybe that's fine. Oh, obviously. So this is just a let s, and then let s equal string from, this is UTF-8, right? So this is, but this is C string, right? C string from pointer as star const, right? So we create a C string from this pointer because it's 0 terminated, and then we create a string assuming it's valid UTF-8. And C string from pointer is obviously in our all-time favorite. We should decide if we use core FFI or standard FFI at some point, so. Hey, did we? Oh. Probably here we want to do a 2 bytes to back, right? I mean, this is, we don't care if we copy 5 times at this point. It's only run once, and then and GL version is this. Let's see. me just unwrap this. We assume it wraps, it unwraps. The nice thing is with all the stuff I hit in Rust right now that I don't know, it will prime my brain. So it's GL version 4.1 ATI 4.2. Okay. So that's nice, but we were looking into our material and then we said, where's all this debug coming from? Who is Fiiish app line 59? Is there still a debug there? Yes. Well, no, this is the final escape. Okay, that's cool. But okay. So it should be rendering one triangle every frame, right? Oh, oh. Am I stupid? Size, number of indices to be rendered. So number of indices, not number of it's a number of vertices. So this is a vertex count here. Nope, this is a vertex count. Well, now the number of triangles is not used anymore. I mean, we still don't have a shader. It used to be easier in old OpenGL. Come on, really? Because we had default pipelines for everything. So we are probably rendering 3 vertices right now. See the untextured triangle in the middle of the screen? No? Me neither. I mean, maybe we can do GL poly mode, polygon mode, GL polygon mode. Maybe we cheat a bit and say, this is a cheat, GL polygon mode, GL front and back, GL line. Is it line or lines? I can never remember. GL line. It will probably still be rendered with this standard. I mean, polygon mode. Yeah, nice try. Okay. So let's assume it's the missing shader, right? So we knew we need a lot of boilerplate stuff. We knew we need a lot of boilerplate stuff. Actually, I'm stupid. I did all of that in Rust already. Alright. I did all of this in Rust already. Let's just double check we're not missing anything. So we bind the buffer, we buffer the data, we enable the I think I'm missing something. Hello triangle. We have the vertices. Oh, it's upside down. That's good to know. I mean, that's just our app, but I knew something was fishy here, but we disabled the culling, so we generate the buffer, we bind the buffer, we buffer the data, we skip the shader, we skipped everything shader, we skipped everything shader, we set the attrib pointer, we enable the array, so bind, buffer, enable attrib pointer, enable use program, and then we need to render it, right? We don't use a VAO. We don't want to buffer it, so I think it's the shaders. We don't have any shaders, so shall we just do the minimal shader work, right? So, and we probably do the shader. Shall we do the shader inline? I have the feeling I forgot something. Let's do the shader thing, right? Oh. So let's just do a pass-through shader. And we do this right in the material for the time being, right? So, sorry. I think my brain is starting to shut down. We can just do a const vertex shader source is equals be basically this, right? That's just saying, okay, this is our attribute, which is bound to 0 in the stream, and we just pass this through. Will this actually? Probably we need to 0 terminate this explicitly, I think. Maybe we could just do this to avoid the... And I think this actually... We don't set precision. Let me quickly check, because I think we need lifetime specifiers on this. So help provided type, yes. And the type of this is actually reference to U8, right? And probably we need to make this static. We could make this static. We want to make this static. Yeah. We just want to make this static. It's temporary anyway. We need to load shaders from a file, right? So basically that is a vertex shader. And then we have a fragment shader. Let's copy that from here right now. Basically, okay, that just sets some color. I just copy it from there to avoid that we accidentally do something stupid in our shader code now. So both of these are not used, and now we can just say, okay. So shall we just... So let's actually do this here, right? So how do we create a shader? Basically, we have gl create shader, and if I do man gl create shader, I mean we have to create the object, right? And we have to tell it the shader type, so it's a vertex shader gl vertex shader, right? And that is basically a gl uint. So we just put this in here, hack vs vertex shader gl types gl uint, and then the same for the fragment shader, right? So let's say self dot vertex shader equals this, and self dot fragment shader equals this, and we probably just need the program. So I want to wrap this, but so we can compile this shaders, right? So let's say we created the shader, so we do a gl shader source self vs man gl shader source, which gets a bit more. I mean, this is the shader, and this is a shader, then the count, and basically this is an array and an array of string lengths. So we just have one entry, right? We have one entry, and then basically we need to create a vs source. It's a one entry array, but we want the pointer of that, and that needs to be a const whatever, right? And then we want a pointer of that, and then I think for the length, if length is null, each string is assumed to be null terminated, and we did the null termination here. So this is just, then we can just say std purger null, right? Too much boilerplate, far too much boilerplate, but I want that white triangle today. Classic. Right. Whoa, whoa, whoa. And this is not self, this is S, and this is S. Obviously, VS is and FS. Maybe we should have a const GLU and invalid. What do you mean VS source not found? Oh, because it's... Maybe let's drag them out. Maybe that wasn't the best place to put them, and just put them here temporarily. That helps the formatting as well. They will be loaded from disk anyway, or pre-converted or something. And one last time. So this gives it a shader source. Maybe we want to write a helper, a wrapper. So that worked. Well, it compiled, and then we do the same for the fragment shader with a fragment shader source, right? We could do error handling here, but maybe, I mean, GL get error. So we could do a GL get error and just match that against what is the possible values here. So GL no error, GL no error does nothing, and everything else just does maybe it's worth to make that a helper. GL error E. This probably will give us an ugly number. And at least we see if we broke the state somehow. So no error at that point. So if we did something stupid like, okay, we didn't compile the shader yet, so just for your reference, so we still need to compile the shader. So if we say gl compile shader s.vs, and here we do gl compile shader s.fs. So let's run this. Restart your Windows now. I don't think so. So that works. I mean, if we explicitly do something broken stuff in here, we should get a GL error. No, we don't, because hmm, hmm. We don't, because you have to explicitly get the... I want to keep the shader stuff light today. We'll do the... So the... the compile shader, you can get the info log, right? So there's a gman gl get shader IV, yeah. And then you can say, hey, give me the status, right? So give me the info log length, and if the info log length is larger than 0, something broke. So let's say we intentionally broke the fragment shader, and we will wrap that tomorrow, but if you could go gl get shader IV for as fragment shader, and that unfortunately, so it wants a gl shader info log length. Shader, no, just info log length. Log length, and the third parameter is a pointer to the GL int that will have the info. So we have a let mute GL types GL int, right? Equals 0, and then we have the let log length equal this, and then this is log length, right? I'm not sure if the types work. We will do all the shader wrapping tomorrow. Boo, 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 boo. Maybe it's time to call it a day. This looks better, right? We could probably omit the type. Can we omit the type here? Because it knows what it expects here, right? So types differ in mutability. So this works, and so to do tomorrow. I just want to show, okay, so our fragment shader is broken now. It's definitely broken, it cannot compile. And we try to compile it, so our log length should be, so you could see it here, log length is 77. So there is some info in the log. Actually, we could get that, but I don't want to right now because I'm conscious of time. So if I comment this out, or just remove it. So our log length here is 0. So we actually do compile this stuff here. So when it's correct, it compiles. When it isn't correct, and to do actually do the error handling and reporting. Right now we're just tagging it together. So we have the shaders compiled, both of them. We have the fragment shader compiled, and now we need to create a program, right? So we need a shader program. So proc the GL types GLU int. It's all just temporary. So proc is. We could probably do all this and then initialize this with the correct value, but and we leave the test here. So we say s.proc equals basically gl create program, gl create. This is all just straightforward. So, and then we have to attach the shaders to the program. So we need to do a attach shader, which gets the program and the shader. So it basically says these things belong together. So GL attach shader, and first the program, so the program, and the order doesn't matter. So fragment shader, I like to do it in the way they are called. So that means, hey, these belong together, and then you basically say, and now I'll link them together. So GL link program as proc, right? And then we could do some error handling. We could get the link status, right? So we could get the program IV and get the link status. So we could do a GL get program IV for the proc, actually GL link status, and then I'm not sure what the GL int. So basically say let mute status equals 0, and then this is mute status, right? Probably some type issue or not. And then we just say, let's just debug status for now, right? So if we run this, status should be 0. I'm not sure what the status means. So the status is 1. I have no idea what the status of 1 means. I mean, 1 is probably success, right? So if, for example, we output a pause here, that's bad. How do we do this? So let's say we have an out back out float 0 here, right? And we just say 0 equals 0.0. That is not used in the fragment shader. Oh, it's a bad example. So, and then we have a in float 0, right? So that should just work. It links together the two zeros, the out and the in. So this status is still true. But if I then have a in float 0 and remove this out float 0 here, bad example, but then the linker should say, okay. In theory, the linker the linker optimizes out plus 0. It was optimized out in the fragment shader. So now the status is 0 because we try to link this together, and it says, hey, stupid, maybe you want to give me what I need. And so the shader compiler compiles the individuals, and the linker combines them into a program and makes sure all the slots fit, and now the status is 1 again. But this is a very bad example, so I'm just gonna remove this again. But this means we are absolutely sure when we have the status of 1 here that we now have a successfully linked shader program, right? So status is 1, log file is 0. We should probably do the log file for both of them, but so be it. We don't need the shaders anymore. Let's just keep them around. And then we actually have to use the program. So man gl use program. So all the man gl So actually from now on use this program, right? So, and that's something we do every time we render. So basically we say gl use program, and that is self.proc. And this shader stuff is hacked in really heavily right now, and it should explode in my face. And it still doesn't do anything. We bind the buffer. Wait. Wait. I'm missing something. So the shader should be okay. We don't have any uniforms. I just want to wrap it for today, to be honest. So I have the OpenGL renderer, the OpenGLES renderer, the materials, the Rust versions, the prototype open on the other screen. I wish I had more screens for you, but you'll have to live with this. So we bind the buffer. Just double check. Just double checking. We actually let's not do blending right now. Just add it and actually GL disable. I wish that was one function that got a true or a false. Let's make sure the blending is not killing us, right? Okay, it's not the blending. So we bind the buffer. We buffer the data. I'm not sure about this. We enable the vertex attrib array at index 0. We enable the pointer with a GL float and the vertex size and an offset of 0. We don't need text codes. We don't need a texture. We do GL draw arrays. What am I missing? What the foo am I missing? I think the bind vertex array. What am I missing? Let me check something real quick. Engine, source, resource, no. GFX, quad. How do I render a quad? We generate the vertex arrays. We bind the vertex arrays. We generate the buffer. We buffer the data. We bind the vertex array. We enable the vertex attrib array. We enable the vertex. I don't get it. We are very close. So in the draw, um, bind the buffer, right? We bind the buffer as an array buffer, and that's the buffer we got. We enable the vertex attrib array 0. We set the vertex attrib pointer. Maybe this code is wrong. Bind the buffer. And we draw the array. What am I missing? Why is nothing showing up? This is actually being called, right? We're not doing something super stupid, so fish main, yeah, fish app. Let's not do the clear. So let's not do the clear. Then in the material we have our hacky. This basically passes through X, Y, and Z, right? Nothing special, and then in the fragment shader it just sets it to red, green, yellowish, bluish. What we could do is we could have a function check GL error and just do a check GL error. I mean, maybe it's telling us what you're doing here. So GL error stays broken until you read it. Oh, well, that was helpful. And obviously this is unsafe. We just moved it from an unsafe block to a safe block. Obviously this failed. So what are we doing wrong? We set 2 hours, which is in 5 minutes. So, and obviously we want to check the GL error. Let's test if we have an error here, and let's test if we have an error at the very end. So if it was, we clear it here and we check it here again, and maybe it's telling us, hey, stupid, GL error 1128. So 1182. Really? 49E, 49E OpenGL error. I'm pretty sure. What is 1182? GL OpenGL error 1182. Invalid operation. So we do have an invalid operation somewhere. I mean, we don't know exactly where. Do we actually have rustlang current line number? Standard line expands to the line number. Standard line. So what I want to do is here. line line as what u32 in line and then what we can do wherever we call is we can just do standard line, right? If I understood that correctly. I'm wondering what operation, and then we can, if that works, we can sprinkle it around and see. If it was OpenGL 4.2, we could have a standard line, not a value. Oh, is it a macro? Yep, it is a macro. It is a macro and not a not a const. I don't know what I was even thinking. I just want a triangle on the screen. On line 132. So it was clean here, and then somewhere in between it got an error. So let's just say we clear it out in the middle, right? So it's still in one line 3.3. So here it was okay, and here it goes kaput. So let's see if it is the use program. I doubt it. So it's broken in one line 28 and 135. So it's before the use program. And this draw arrays, it says, what are you trying to do? So let's do one more check. I think the draw arrays will break because we haven't bound the correct info. So it's in 126. So this is just a follow-on error. But in 120, wait, this results in a is generated if index is greater than or equal than GL max vertex attributes. I mean, this is 0, right? This is frickin' 0. So this can only fail GL max vertex attributes. Oh. Oh. What if we move this from here to here? Oh. No. So it's in 128 now, so up. I mean, where did we find the invalid operation? So I want to do one thing here. So it's GL invalid. Wait. Invalid value. I'm gonna extend the check here and say, how do we do this. Don't do this at home, kids, but basically I want to do a match inside here and say otherwise just return E. Will this work? It should. Okay, this works, and then I say if it is a GL invalid value, we map that to invalid value, right? I'm just not sure. To string. Well, probably we can just do this and have a reference. I should stop. I should just stop. So let's do the to string here to make sure the types match. I mean, so it's 1228, but 12. So if it's 1228, well, 1228, 1282. So if it's 1282, we get a right. Oh, okay. So that matches. And 1228 is invalid operation, not invalid value. So it's GL. We need to extend this anyway. Operation, and it's a bit sad that there's no name as val string. Maybe there is. So we get an invalid operation in line 133. So GL enable vertex attrib throws an invalid operation. According to the standard, it can only create an invalid value. So GL enable vertex attrib array, GL invalid operation. How can that be? And he's basically doing the same thing, right? Use program bind buffer, and for a 0 he gets that's old school. Yeah, it's basically this code, right? I mean, we were using compat mode to. Oh, basically, just for reference. Oh, thanks for not copying this. I'm a klutz. I mean, I'm using compatibility mode, and it's not core compliant because we don't have a vertex array. And I was constantly stumbling over my code here that basically says scan vertex array. Ah, I ah. I have it in my code. I mean, so what we basically do is we generate a vertex array. So okay, we have VAO ID. Okay, ID VAO GL types GL uint. And basically, let's go and I'm so stupid. So it gets a size and the pointer to the thing. So I just the usual in the somewhere here GL again vertex arrays, right? We say we want one mutable s dot VAO, and then we need to bind that. And we need to bind that preferably before the buffer, right? So we just say man gl bind vertex array, and that just gets the. We didn't give opengl the array to work with, so this is s dot VAO, and that's all. Don't tell me that is all. Don't tell me that's. Oh, okay. Missing VAO fair. We didn't add that, so VAO is. That's what you get when you call it buffer, because in the other code that was the buffer. 125. Oh, self. I'm tired. I am tired, but we have a triangle with an untextured but shaded triangle. Don't believe me, it's shaded? Oh, I show you it's shaded because I can just use. Oh, let's say we have an out vec2 screen pause, and then just say screen pause equals vec2. Basically, we can do a pause a pause dot xy, right? And then we have an in vec2 screen pause, and then let's say the blue value is screen pause dot y, right? So you see can you see it? But it's slightly more blue at the top than at the bottom. I mean, this is okay. We have actually what we then want to do is absolute value, because we go over 0, we go into the negative, and then it fades away. So let's mirror it. So it gets very blue at the top here and very blue at the bottom. Actually, let's multiply that by 10 just to make it more pronounced. We're just playing with a shader at this point, so it's probably too much, but you can see that it's working, right? You do see that it's working. That vertex array object, it was not so smart, right? I mean, let's do something different just to make this a bit more fun. Let's say let y equals self dot total time dot sinus, right? And just say plus y, just to show that we update that buffer every frame. As f32. Yeah, we could probably do the S in the... Wait, what? It worked and then it stopped. I mean, we can enable the clear again. We can enable the clear again. Oh, so it was overdrawing because we weren't clearing, right? So maybe we multiply the sinus by... and then we just add that to everything, right? We could do rotation and everything, but we're gonna add uniforms anyway, so... Actually, let's do the same for x, but with a slightly different period. So let's do it slightly faster, 10% faster, and then just do plus x plus x plus x. I should have read the red book. I was doing that from the top of my head and I haven't touched that in years, so this is working very nicely, right? So I probably should be able to say, hey, aspect ratio is broken completely for obvious reasons. But we do have a triangle. Plus some hacking code, but that's okay. We clean that up tomorrow. So we put that. So render untextured triangle. And basically render triangle with shade. Well, we render with custom shader, right? Custom shader from file. And then what I want to do is encapsulate shader and program. Shader and programs, and I also want to start to support. Do we want multi-material support? I mean, here's the thing. If I go into... nope. Let's commit this first. So we updated the to-do. We updated the app for the result handling. We did the unwrapping here. We started to render. And we created the material. So add material, add triangle rendering. So, but I want to do something else because I want to have some fun. So what we could do here is, what we could do here is for nothing in 0 to, I don't know, let's do 10, right? Well, actually, let's use the int I here and say I plus I times 5.0, right? It's an integer. So let's say let fi equals I as f32, and instead of giving it an offset, we give it an offset in the period, right? So plus fi, just for x. Just having fun. Okay. Let's say t equals self dot total time plus fi, and we do a f32 here, right? And then that also makes this loop a bit cleaner because we just say t sinus, and here we say t1.1. So basically draw 10 triangles with a slight offset in the period. Chaos. Let's not do the scaling here. Oh, let's just add a constant here, right? So pi 3.14. Right, so basically make a cosine out of sine. Now we're having fun. Oh yeah, I wanted obviously half pi. Pi is 180 degrees, which is bad. So maybe make this a bit, let s equal 0.5, and here we just use s, 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 right? So that's the same. We just replaced the size with a constant, well, a variable. And now we make this a bit smaller. Well, let's still make this a bit smaller. Maybe the colors aren't the smartest choice right now, so let's make the triangles, that's in the shader, that's just the standard shader I copied, so let's actually say, yep, let's do it like this. Yes, we could do a vector operation here, but we're playing around, right? Should stop drinking coffee. Nice, useful, yes, and now I'm gonna do one more thing to this. How about we don't render a triangle and we render 2 triangles instead? So we do this, which will look nicer anyway. So it's minus plus top left minus minus bottom left plus minus bottom right. So it's this triangle, right? Okay. So it's top left. So this is top left, bottom left. So this is top left. This is bottom left. This is bottom right. And this is top right. Probably should have named them differently, but so this is, so we want another one. Basically, we want bottom right, top left, right? So we want bottom right, top left. So bottom right is V2, top right is V3, and top left is V0, right? Maybe. And we, oh, wait. Let's just do this once. What did I mess up? So the material has one triangle and then a second triangle, right? Oh, these here look. Wait, what? So let's just say that x equals 0. Let's remove the animation just for debugging for the moment. What did I do? So the vertices are top left, minus x plus y, bottom left, bottom right, and the top right. Yeah, this top right here is not the top right. This is the top right, right? This is the top right, right. Ignore the aspect ratio. We're not compensating for that today. We just, okay, we have a square. Bad cut and paste juju, so we can remove this to get the animation back. And all these quads now are exactly one draw call. Well, this one quad is exactly one draw call. These 10 quads are exactly one draw call with 20 triangles in it, or 60 vertices. And actually I want to scale the x a bit, so let x equal 5.0 times x, and the same for y, just to make it a bit. We could just fold that into the amplitude here, but I want to pretend I have a projection matrix that would do that. Probably 10.5 is a bit too much. Let's make this smaller. This is nice, right? And then we can go into the material. Didn't we? We can use the blending. Blending won't do anything because they all have full alpha right now. So same look, but we could go into the shader and say they only have like 50% alpha. Just for showing that the blending is working. If we need blending, which we will need, so that works. Maybe we even want just 25%. And we will disable the cull face because we want back faces culled in theory. And let's see if our winding order is correct. Seems like it. So if we were to change the order here, right? If we switch 3 and 2. So if you look at the front of the triangle, the winding order is counterclockwise, and if you look at the back, so from the inside, which should not be rendered, it's clockwise. So we get the back face culling. So, but we don't want that. And actually, shall we just? Uh-oh. Uh-oh. Let's go crazy. I mean, we're rendering a lot of the screen position is dependent on the color is dependent on the screen position. That's why we get constant colors and not textured individual triangles. So, but if we do so many, we probably, I mean, we're playing around with parameters that will be tweakable tomorrow. But after such a long day, I think that was 7 hours. Well, no, only 6 hours from 0 to rendering from scratch. So, I mean, all we need now is textures, and then we're basically away from. We still need layers and shader types, but apart we need uniforms. We probably won't even need uniforms for a long time. I think the only thing that uses a shader uniform in Fiiish is actually the background animation, the color thingy there. So oh, this looks good. This is almost hypnotic. Hypnotisch. Can be. And now we can't. Yeah, we don't handle that very well. We could do a plus, right? Ooh. I will commit this. So what did we actually do? I mean, in the end, we just played with render quads, disabled the cull face. I wanted to do something else. Oh. So enable back face culling, render quads, and well, render quads to triangles instead of triangles, and render more quads. It is backface culling. Backface. Fetch, rebase, push. As always, all of this is on my GitHub. We really need to. So enable backface culling is here. I'm gonna paste this into the chat real quick for your reference. And then we cut a lot of corners today, I know. But we wanted to get to this point fast. Actually, we're a bit further than I had hoped. So, as always, thanks for being here. We will continue tomorrow. Until then, see you.